Hi YouTube. Today we're going to talk about maths and surveying and a little bit of theory behind that. So, good old days before we started to survey with laser gizometry. Typically a builder would use a 3-4-5 triangle, which is quite simply using the Pythagoras theory. 3-4-5. Where Pythagoras had it that the sum of a squared plus b squared equals c squared, so 9 plus 16 equals 25, and that was Pythagoras. And not to get into the who discovered what and when, but this theory goes back before Pythagoras, but it's been attributed to him, so we'll live with that. Now, there's another theory, isosceles triangles, such that when you have an isosceles triangle, that length and that length, this angle A and B will equal B, and the sum of A plus 2b will equal 180 degrees. So it's all simple maths. Now the problem with the 3-4-5 triangle is obviously it's the simplest, but the problem with that is you've got to set that out fairly accurately to ensure that that angle there, get that in frame, that angle there is 90 degrees. And so you can set that up on site. It is relatively easy, but you need to be careful, and these things become quite, to get the accuracy that you need, these things become quite large, cumbersome bits of wood typically nailed together, and they're good, but you know, hey. So going back to the even good older days, the Romans had a system which they used, which was essentially a cross, slightly isometric view here, and they called this the groma. And the idea was that this would have a lead weight bob in the centre. This whole thing would be suspended from a post driven into the ground, and these beams would be at right angles to each other and of equal length. Each arm was of equal length, beams at 90 degrees, lead weights as bobs hanging vertically. So this whole thing would be set up on the posts such that all of this would be vertical, and such that when you viewed between one bob, the centre bob, and the next bob, you'd have a straight line. And obviously therefore, if these are maintained at 90 degrees, when you viewed and sighted down the other side, you'd have another line. And so this piece of kit was sensitive. You needed to ensure that this was always at 90 degrees, and it was the head surveyor would look after this piece of kit, and as far as I can understand it, I've not seen anything to contradict this. This thing was transported as a fixed piece of kit. Now this was sizable. These would be a couple of foot across easily, and as I say, they needed to be maintained at 90 degrees to give yourself accuracy. Any slight divergence in there would become multiply itself out by a very large divergence if that was slightly out. So where am I and why am I telling you all of this? Well, if you take a triangle with a baseline and a line coming down through here, now between these points here, let's call that, let's start with X, Y and Z, and let's take the midpoint between X and Y such that that's equal to that, And let's take a line from Z to that midpoint, and that's also equal. And then we've got two isosceles triangles. So we have an angle here, which we'll call A. We have an angle here, we'll call this B. And we know about isosceles triangles, as I've just said, that these two angles here, C, are equal. And this angle here and here, call this D, and we know that they're equal. So what do we know about this triangle? Well, we know that that's between X and Y is a straight line. So we know that A and B, A plus B equals 180 degrees. And we know that A plus 2D equals 180 degrees, which is the included angles in a triangle. And we know that B plus 2C equals 180 degrees. So how does that help? We need to know, or we would like to know, and I'll explain why we need to know this, that C plus D equals something. We don't know what, but it's actually easy to calculate. So if we substitute, make sure I'm trying to keep you in frame here. If we substitute then for D, so D equals 180 degrees minus A over 2, and similarly for C equals 180 degrees minus B over 2. So to write this in longhand, so I can keep track of all of this for you, what I'm trying to get to, then you have D equals 180 over 2, which is 90, minus A over 2, so that's half A, and C is the same, it's 90 minus a half B. So as I'm working through this in an extremely longhand kind of way to make my point, C plus D then is, C plus D is 90 minus half A plus 90 minus a half B, which equals 180 minus a half brackets A plus B. Well, we know what A plus B is because we worked this out up here. A plus B is 180. So C plus D equals 180 minus a half of 180. So that's 90. So the reason why I wanted to get to this, and I wanted to go through the rather contrived maths here, is that C plus D for any angle of A or B is always 90 degrees. So why is that useful to us? It means that if you are out on a field or in a site or whatever, and you have a piece of wood, a piece of metal or whatever, where you have the middle point between X and Y, your piece of wood, and then you have another piece of wood which is exactly half of it, and you connect it there, then that piece of wood will always have an angle there of 90 degrees for any angle between here and here. And that means that when the Romans and it's even attributed back to the Egyptians and beyond, invented the groma, which required to be transported in a box and kept and calibrated to 90 degrees, was actually not an absolute imperative, because with a simple piece of wood hinged in the middle and hinged to any angle that suited you, you would always have a 90 degree included angle. So this angle here, the two angles together make 180. None of those matter, because if you wanted a 90 degree angle, you always had it between that point, wherever that was rotated to, and this point here and here. So between X and Y and this point Z, for any angle, would always be 90 degrees. No calibration, instantly set up, easy to transport, and obviously you can make this out of very lightweight materials now. And so that's really all I wanted to say. I wanted to share that with you. It saves making a 3-4-5 triangle on site. You have just the requirement for a piece of wood or metal or any other material with an angle here of equal length. So good to go. Hope that made sense. Enjoy. Thank you.